Hi, welcome back. And I must just tell you, time has really flown. We have got very little time to handle this question, but we've been inundated with requests around general solutions. So let's look at this question. I'm going to move relatively quickly because I want you to auto benefit, and I want to demonstrate the two ways of doing it. So whichever method you've been shown, you can cope with. All right, it says determine, and this is thanks to, I think it's Lee or Leah, I'm not sure, but let's assume it's Lee. Determine the general solution of this thing here. Now, the first thing I would do is I'd say this is not in a format I recognize. So I'm going to first get rid of this denominator. And to get rid of that, I'm going to multiply the whole thing through by cos x. So it becomes 5 cos x equals 4 cos x. However, I do have to bear in mind that this means that, whoa, hang on, I think this might be a mistake. I think there might be a square there, because otherwise this question doesn't make sense. Yeah, I'm pretty sure there's a square there. So I'm going to put it on Lee. I hope I'm right. But it's too easy otherwise, because you could have just cancelled those causes and then you would get a whole lot of gobbledygooch. You'd have 6 minus 5, which is 1 equals 4. I'm pretty sure there's a square there. Maybe you can just Facebook us quickly and confirm that, but I'm sure I'm right. So cos x may not equal 0, because if it did, then the whole thing would be undefined. Remember, you can't have a denominator of 0. So we keep that in mind because it probably will affect our general solution later on. So now what I have is I've got 6 cos squared x, and now I'm going to bring this over, so I'm going to get minus 9 cos x equals 0. Right, now once I'm here, I can see I could divide by 3, and if I do, I would get 2 cos x, cos squared x, minus 3 cos x equals 0. Now at this stage you would take out cos x as a common factor, giving you 2 cos x minus 3 equals 0. Okay, this question is faulty in some way, so I'm just going to doctor it because it's doing the strangest things. Yeah, no, it definitely is doing something weird here. Anyhow, we will deal with it and we will get it. I'll just doctor it a little bit. I think what I'll do is I'll change this to a plus sign, okay, which means that when we bring this over, this is going to be coming, sorry about this, Leah, I think there's something faulty here, I don't know what it is. It's either our error or maybe just a transcription error, I'm not sure, but I'm going to change it so that it's possible to work with it. If I do that, this comes over as cos x, and now it's much more doable. And now we take out the cos x as a common factor, giving us 6 cos x minus 1 equals 0. Now, at this stage, that means, and if you think back to your algebra from grade 8 and 9, if you had something like this looking at you, you would answer, that means that x is 0 or x is 3. Same thing here, that means that cos x is 0 or 6 cos x minus 1 is 0, which means cos x is equal to 1/6. Now, because we were clever and we put this there immediately, we know that there's no solution on this side. Okay, so we can just scrap that because we know that cannot happen. But over here we can carry on, and this is what I want to spend the last few minutes mentioning. The other method of doing this is to work with what we call a reference angle. Now what we do with a reference angle is we pull the calculator up, of course good idea to clear it, and we're just going to go second function cos, and we would, in brackets, go 1 divide by 6, close the brackets, equals, and we get a reference angle of 80,41. If we round to 2 decimal places, I suppose the question would have asked you something like that. So it's 80,41. And then you would say to yourself, which quadrants are we in? Well, if we look at our drawing, our cast drawing, we know that the only place that cos is positive is first quadrant and fourth quadrant. So what we would do is we would say x is equal to 80,41 degrees plus k 360. And over here we would say x is 360 minus 80,41 degrees plus k 360. Okay, this one's finished. This one we still have to do. We pull up our calculator again, and we would go 360 minus the answer, and we would get 279,59. So 279,59 plus k 360. Now that's the reference angle way. Just a little warning here, if there had been a negative here, And in fact, I'll just mention then all we would have done is work in those two quadrants. And if there was a complicated angle here, we would have had, say, 2x, yeah? And then it would have been a 2x, then we first would have divided. Now, the other method I was showing you earlier is just this much easier, because what you would do is you would just go straight to x equals plus or minus shift cos 1 over 6, and we would get 80,41 degrees plus k 360. And you'll say to me, but hang on, that solution is not the same as these solutions. The good news is that they are. If you take negative 80,41, let's just bring the calculator up. Let's clear it. If we take negative 80.41 and we add on 360, you get your 279,59, which is exactly what the other solution told me. Okay, so all that happens is this is a condensed form of these two, but it's absolutely fine. Just as a last reminder, I'd like to mention, let's take cos 2x equals minus a half, something nice and easy. And here again, if you're going to use the reference angle method, you would first bring this up. You would clear your calculator, you would go second function cos, and you would only use the half, you would not use the negative. The other method, we just do that. And it would give you 60 degrees for the reference. Oops, helps you get the pen. Reference angle is 60 degrees. Then you would say we are dealing in this quadrant and this quadrant. So it's going to be 2x equals 180 minus 60. Notice immediately I put the K360 on. Don't put it on later, because that's one way to get yourself into big trouble. And this is 180 degrees plus 60 plus K360. And somewhere you must have k in elements of z, remember, otherwise they're going to wonder what k is. So 2x is equal to 120 plus k 360, and therefore x is 60 degrees plus k 180, and you would do the same here. You'd say 2x is 240 plus k 360, and you would do the same thing. So just remember that's all that you would do differently if your angle was more complicated. Anyhow, I'm sorry we seem to have run out of time, which is really, really sad, because we were just getting into it. But I want to encourage you, because we are going to be screening more trigonometry, more analytical, everything to do with paper 2, some stats, everything in the next few hours. I think the next 4 hours, if I remember rightly. So definitely stay tuned. It won't be live, but at least you might see some of the questions I didn't get to in the live session. So please stay with us and keep watching, and all the best for tomorrow. I hope your paper's a good one and that you have great success. Thanks for joining us. Bye-bye.